and TF IDF we can calculate by the formula as shown in this slide. And the last technical about the natural language processing related to work embedding. TF IDF is an important picture. However, it's not describe the relation between the work, and so that work embedding technical is very good technique for the natural language processing. In the work embedding, we have many kind of work embedding. For example, SIBO or skigram, proposed by Thomas Microvet et al. 2013. And here is about the SIBO from the Thomas Microvet et al. 2013. And from the one hot vector, we can use the neutron, look like the neutron network. We can build we can build to find the work embedding for work. And skigram is a reserve with the SIBO. And another work embedding technique here, you can see that Glovo, fast stack Albert. Glovo from the Stanford LNP research group, and fast stack from the Facebook AI research, and but from the Google AI. And here is the number of citations when I check with this down. The model, the bird architecture, you can see that in this slide from the pre-training and deep bidirectional transform for language understanding. And in the natural language processing, there are many tasks. In the last column, you can see that it are related to the linguistic. And the second column, you can see that is some natural language processing tasks. For example, information retrieval, information extraction, name entity recognition, sentiment analysis, work send, and this by.
I'm sorry, sir. I'm interrupting in between. It would be really good for us if you could go a little bit slower.
Slow. Okay.
Thank you, sir.
Thank you. And co-reference resolution or discord analysis. And in the third column, you can see some advanced natural language processing. For example, machine translation, automatic summarization, natural language generation, question answering system, dialogue system, and image captioner. Is some advanced natural language processing here related to chatbot we talked today. However, natural language processing is difficult. Why is it difficult? Because you know that language is ambiguous, and language is flexible, language is subtle, and language is complex. And there are many hidden variables, and we had to face with the problem of scale, problem of the sparsity, and long-range correlation. That's why LNP is more difficult. And the key problem here is we had to representing a meaning and language pre-suppose knowledge about the world, and it reflects the survey of the meaning, and it presuppose communication between the people, so that we need the natural language processing in the many tasks. In the as a talk about the natural language processing and what is the task in the natural language processing. Next part, I will talk about the deep learning and how to deep learning to how to use deep learning to solve the problem of natural language processing. You know that machine learning is one main approach for the artificial intelligence, and deep learning the main approach of machine learning. What is machine learning? The definition by Tom Mitchell, he says that a computer program is said to learn from exponent E with respect to some class of task T and performance measure P. Is performance a task in T as measured by P and improved with the pre-experiment E. is a definition from the Tom Mitchell. For example, if we look at the flying checker, T means that's the start of flying checker, and E means that the experiment of playing many game of checker, and P means that the probability that program win the next game. And how about the recognizing the cat? T here is as a task of identifying cat in the picture, and E means that the experiment of looking at a lot of cat picture, and P means that probability that program will detect a cat in the picture. We can divide machine learning to three groups. The first group is supervised learning. The second is unsupervised learning. And the third group is reinforcement learning. And another group is a mix between unsupervised and semi-supervised. We call it is semi-supervised learning. How about your artificial neural network? You know that about here the biology of neuron, biology of neuron, yes. And with the biology here and here the artificial neural network. In the picture A, you can see that in the human neuron. In the picture B, is the artificial neuron or hidden immunity. And in the picture C, the biological synapse. And the last picture, ANN synapse. And when we zoom in the one neural network, you see that we have the input and the cell body here, and we have the activation function, synapse here. And the network chaining is mean that is the process of changing the connection weight and threshold of neuron based on learning pattern to satisfy certain condition. It's a neuron chaining. And in the neuron chaining, backpropagation is a very important process. This process that you update the weight. For example, here the one way to update the weight. With the weight is from the pre-wired neuron, and N is the mean that learning rate, and GT means that the current gradient. And you can see that the backpropagation here is a neural network. And how about the deep learning? Deep learning built from the neural network. And machine learning very different with deep learning. You can see that the difference between machine learning and deep learning in this picture. In the machine learning, we do picture extraction and classification separately. However, in the deep learning, is the same process. And there are some difference between the deep learning and machine learning. With the data, we need the big data for the deep learning. Require machine learning machine with the GPU and strong computer, and maybe it take a long time and difficult to data interpretation. And here is the scientist that got Turing Award in last year. This look like the Nobel Award for the computer science. We don't have the Nobel Award for the computer science. We only have the Turing Award. And they published the Deep Learning International in 2015. And when I checked it in the last month, with this a very large number of citations. And it's the same, we can divide the deep learning is the same with the machine learning. It means that we have three groups: supervised deep learning, deep reinforcement learning, and deep unsupervised learning. And combined between deep supervised learning and deep unsupervised, we have the deep semi-supervised learning. And here is some deep supervised learning, FNN, CNN, INN, LSTM by LSTM. Here is a recurrent neural network, RNN, in the supervised learning. It means that we have the gate here, and from the gate we can remember or forget the last step or the last picture for the